Alright, now we'll move on to this unit here. It's quite similar to the first unit that we went over, although there are some slight differences. So we'll go over some of that and some testing. So as for the power supply, I'm reusing 3 lithium-ion cells, 2 of which I recovered for some old laptops, and this one I got from an old hand drill and recovered myself. These cells here are connected in parallel. However, they are connected in series to the circuit here. And here I'm measuring using the probes from my multimeter, diagonal connection across the battery pack there. And we get an output voltage of 4.2 volts there. And for the other diagonal connection, we have a voltage readout of 3.7 volts there, minus the reverse polarity. Alright, so for protecting and managing the battery pack, I'm using this battery protection management board here, which takes in the in-series connection at 4.2 volts and is connected to the positive and negative terminal. And then I have the P plus and P minus connections, the power cables, one going to the positive input of this driver here, and then the negative power cable is directly connected to the laser diode. So for the driver, I'm just reusing a 7805 linear fixed regulator, and I have that heat sinked here. So I have the positive input coming from the battery management board, which is coming from the power supply going to the positive input here. And then I have another positive input wire connected directly to the heatsink here, and that gives me excess regulated current. I'm using a 3.3 k ohm ceramic resistor, and then I have the positive output pin connected directly to the laser diode, and the ground pin is connected directly to the heatsink here. So as for the laser diode module, it's really quite simple. I simply fitted the brass laser diode module inside of a steel cavity, and I have that secured inside of this aluminum heatsink here. And here I have the laser powered up here. For powering on the device, all I had to do was attach this one alligator clip to the positive wire there. And here we can see scattering effects of the laser here. As you can see, the laser is entirely in parallel here. So now I can adjust the focal length to a very tight spot within the beam here, and then we can do some burning tests to see how powerful this thing really is. You can see how fast this laser can poke holes and cut through tape. Alright, so I can poke holes at a fairly fast rate here. There you can see the holes in the tape. Now let's see how fast this laser can cut. Relatively quickly. And here we can see some pretty harmful scattering effects. Alright, so after some basic testing here, it would definitely appear to me that both of these laser units are relatively the same, especially in terms of their overall power output, both units being approximately 30 milliwatts at least, and that could be a plus, where it peaks at a certain point and drops back down. But yeah, these are definitely very hazardous devices, and it just goes to show how powerful some of the cheap surplus you can buy off of eBay really is.